test. Today I'm gonna test a 10.4 inch diameter times pitch of a 3D printed propeller, which is clockwise and counterclockwise, which we can see from the fret shape of the blade of this propeller make. For the clockwise propeller, it's made of polycarbonate with a thickness of the plate around 0.5 millimeter. As you can see, this is very thin material and very thin shape, so we gotta be careful, but we can ensure that it's robustness and stiff, for which we will test this propeller on the bench test. And furthermore, this polycarbonate said to be the strongest material that used on the 3D printer technology compared to PLA, ABS, or resin and such as. So now we'll give a go on this motor. So we're gonna flip this propeller to make the direction compatible to the clockwise motor and give a downward force to the mass. And after that, we should tighten it by M6 bolt, because we're using the M6 outrunner shaft also. And we see that what my propeller do is it'll be compatible with a series of motor like this with an outrunner shaft. See, it is mounted on the motor, or the soft tightening BLDC motor that fit. So you can see here it's only a very few heads of the threaded profile. So if I made the propeller like the APC, which has a hole inside but not a thread to tighten it, so I gotta have if you can see, it's a extrude cut of a hexagonal, so we can insert the nut to fit the cut like this. Alright, it's just a intermezzo for us, so we gotta give a go on the clockwise one. So let's give a measure. Okay, it's around 659 grams of static weight. And anyway, this propeller is actually so light that if you gonna weight it on the mass, it will only weigh 5 grams compared to our propellers that actually usually more than 10 grams per propeller. So kind of using the same battery, HRB 2200 mAh. So yeah, it's connected. Got a good spot to see the. Okay. Alright. So should we go? Oh, and always the reflecting paper to get the tachometer to take your RPMs on the propeller. Should attach it near the shaft of the propeller to make it easy to know the actual RPM that propeller is actually rotating. Sorry for take a while. It should be like that. Okay. Okay, here we go. So watch it out. Actually, the noise made by this propeller is quite just a bit rather than other propellers that I tried before. So it's on a 2,150 RPM. It's doing 400. It's now 300 concept. So gotta turn off a bit. I'm just gonna make sure this propeller is tight enough or not. And our propeller is actually not that hot, it's just a bit warm. And actually that the propeller is making noise not because of the rotation or friction, but maybe it's because you should know, look around in this 3D print propeller, it has not really a good surface finish, and maybe it's frog in the middle a bit. Like you can see there's a bit kind of crevice or perhaps notch on the hub near propeller. But anyway, we just gonna give some good to make it rotate at the maximum capacity that it can retain. So perhaps once more before we change the propeller. See, you kind of see that sound of it's lowering the pitch load or whatever. So it's now actually 3,000 RPM. more, but to get to the failure point. So now we know that uh, the RPM is actually reaching more than 3000 RPM, but I think it's real close to the fail in a 2100 RPM, I guess. So if you're about to initiative with making the 3D printed propeller, you probably I personally really suggest the 3D print, but make sure the plate thickness that should be more than 0.5 millimeter to get nice thin, but it's just pretty good for 3000 RPM, which actually could carry a NATO thrust of 100 grams. So yeah, if it times by 4, it could reach 400 grams.